Hello, today we're doing construction proofs 2 on angle bisection. So, first topic, quick review. In our last video, we did a proof on angle duplication, where if we have an angle, we can recreate the angle without using like a ruler, just using a compass and a pencil. Today we are going to do angle bisection. So basically, what we're gonna do here is I'm gonna draw an angle. This we have line, any angle. All right, and I'm going to take the compass, and I'm gonna go from the end point, and I'm gonna make an arc like that. We're gonna call the points it hits A and B. And this point is gonna be O. Then after that, we're gonna take it again, and we can make this as big as we want to, really. And we're gonna create another arc up here. Take this, create another arc. And if we put a point where these two lines cross, and then draw a line between O and that point, these angles are now split in half. So the measure of this angle is the same as the measure of that angle. Now I drew the line a little bit off, but like, you can see how close it really is. So now what we're going to do is we are going to prove that using these two curves are equal. So I'm going to further this a little bit, and I'll show you why. So let me get a new page here. Basically, I'm going to draw this again, and I'm going to show you how we're going to prove this. So our proof outline for this, we have our angle. We have the compass, which is going to create our arc between here. So this is going to be point A, and this is going to be point B, and this point O. Now, in the last video, we showed that these two, by doing this, these two line segments are now equal because it's the same distance from O to A as O to B to make this curve. Next, what we're going to do is we're going to draw, again, the little arc up here, and then again. And where they intersect, we're going to call this point D. Now, if we draw a line from point B to point D, and we draw a line from point A to point D, because we drew these two curves with the same length of compass without changing it, these two are now the same. And then lastly, by bisecting it like we did in the proof, we go like that, bisect the angles, this side length would now be the same. And now notice triangles OAD and OBD are now the same by SSS. So, prove that, we're going to make a 2-column proof. I made that way too small, but it's fine. Statement and reasoning. So the first thing we're going to do is draw the arc AB. So draw arc AB, which we can do because it's a possible construction. Now, next, because of this construction, we know, like I already said, that segments OA is congruent to segment OB by defining that arc construction. Now we're going to draw arc AD. This curve right here which is a possible construction. We're going to do it again and draw arc BD, which is, again, a possible construction. So now, like I already said, we know that if we were to draw a line between AD and BD, which we did, segment AD would be congruent to segment BD because of the definition of those arc constructions. Now, we know that segment OD is equal to segment OD because everything is equal to itself. Move my paper a little bit. Everything is equal to itself, which means that triangles OAD is congruent to triangle OBD by SSS in rows 2, 5, and 7. No, 6. 2, 5, and 6, my bad. Which means that angle AOD, which is this angle the angle right here, this angle, and is equal to angle BOD, the other one, this angle, by CPCTC, which means congruent parts of triangles are congruent, on number 7. So that proves that these two angles are congruent. Now we can apply this to some other cases. Now what we can do here is we can use this to find a circle within a triangle by angle bisection. So what we can do is I'm going to draw a big triangle, and it's going to be asymmetric. It works if it's not asymmetric, but it looks better if it is asymmetric. That, and then we get a long one here. Probably shouldn't have made that long. Good enough. There you go. Now what we're going to do is we're going to do the same thing as before. So we're going to take our compass, make an arc. Then we don't really need to change the size on this one. We can just go boom and boom. That was bad. Boom. And they cross right about there. And then we're going to draw a line between here and here to as much of the edge as the triangle as we can. So now those two are bisected. Now we're going to do it again for this one. Put it on the point, draw that, take another one, go boom, that one, boom. We see they meet at this point. So we can take this, then up to here and to here. That was bad, let me move that down a bit. Right there, that's pretty good. Then lastly, this one here, I'm going to do the first one the same size, but then I'm going to shrink it for the other one. So we have that big curve right there. I'm going to make this longer here. So we can do that. And we can do that. Oh, I'm way off. Yeah, I am way off. How am I that far off? Alright, but basically what'll happen is these 3 points will go somewhere near each other. In this case, it's right here. If they were, like, truly bisected, they would all end up in one point. They would all intersect at one point. So you see how, like, these two intersected right here? And then they intersected here and then here? That, like, They would all intersect at one point if these were all perfectly bisected, but, like, they're not. So that would put this right here, and we can use this to create a very well-known proof, which I've also forgotten the name of. Bye.